Good afternoon, evening, rather, students. How are you today?
Evening, sir.
Mhm.
Evening, sir.
Hey, man. I hope you guys are fine.
Evening, sir.
We
I'm
will.
okay, and you?
Hello, Delvita, I see you. Somebody was saying something a while ago. Okay. Oh,
Sir,
it
I
was
said
your
I
name.
am okay, and how are you?
Oh, me. I'm a little tired. I was actually dozing at maybe I got about maybe a half an hour to a 45 minutes nap just now. Yeah, 45 minutes nap just now, and I'm just it's been a hold on 1 minute please. Uh, yeah, sorry, yeah, so yeah, I was just posting a while ago. I'm a little tired. Semester's a little too stretched for me, but it is what it is. It is what it is. All right. Without any further ado, let's just get this thing done and over with. I still have one or two little areas to look at, and I really want us to finish this syllabus. Um, oh Lord, did I give you that one? No, I didn't. Did I? No, I think we ended it there. I think that's where we ended. All right, let me just look at this one for a quick share screen, a quick revision. Example number 6, please. Example number 6 is our revision and revision question before I move into something else. Same differential equations, but example number 6. Start from it, please. I'll give you 5 minutes. It's a little longer. Start from it, please. All right, I know you're supposed to finish a question. Do I have an answer?
All right, sir. What I got
Mm-hmm.
for the particular solution is y equal x to the fourth over 4 minus x to the third power plus x to the second power minus 5x minus 21 over 4.
Very good.
I got it, sir.
Very good. And 21 over 4 is going to be the same thing as
5 on 1 over 4.
5 on 1 over 4. Very good. Excellent. Excellent. What about the rest of you?
Yes, sir. That's what I got. Sir, we can use a decimal format for the 5 on 1 over 4.
To be honest with you, Abby, I don't like decimals, especially when we're working with things like these, because we're going to be losing some of our answers. So I would
Okay,
rather put it.
sir.
I would rather put it either improper fraction or mixed number. Leave it as a fraction, hon.
Okay, sir.
Mm-hmm. And let me just give you a little a further. Yeah, you see, when you work with decimals, you throw out a little bit of your answers, and I'm going to give you a little bit of an example. So, as I said before, my time has been spent, putting together notes like these for my CAPE students. And there's a question that they asked on one of the past papers, and I did the first part of the question, and then when I did the second part of the question, well, before I did the second part of the question, I said, why would they give this question in an exam when the students wouldn't have a graph how to do the stuff? And then I figured out how to do the question with the graph, and I say, you know what, let me do the question with the graph first. Did the question with the graph, and a piece of the graph had a reading of 5.2, which is not a problem because I could literally read off 5.2 on the graph paper. But another section of something was negative, and I read it as negative 8.7. But really and truly, it looked a little off. But I say, you know what? It falls halfway between. Let me just put 8.7. And when I calculated it, I got an answer, and I say, you know what? Let me do the calculation another way. I did the calculation another way. Let me see. The first calculation I did got like 30.86. The second time I did the calculation using another method, I got 30.92, something like that. And I was like, no, man, the values are running up and down too much. And then I said, okay, fine. Think about it. In the exam, the students are not going to have a graph paper. So let me do the question how they would expect the students to do it following this. And when I did the question, I got an exact value, like 30.7 something. And that would have been the exact value. Why? Because those are the exact values that the exam would have given. So Aviana, the point I'm making is if you go and you do some estimation, we may have many varied and different answers. And we have to be very precise as science students. A difference, 0.1 makes a big difference. Final example, someone who is doing, say, chemotherapy and will need to be exposed to, or any X-ray, MRI, whatever it is, and will need to be exposed to a certain number of rays, RAYS, and we don't take, a keen interest in the exposure. And I said, sure, 0.25 never kill them all. But you recognize when they get the extra 0.25, it damages some of the cells and will literally kill somebody. And they will come for you. Trust me. Even though the parent is very mature, they will come for you. And they will go at everything at you so that your practice gets shut down. Right? So we have to strive for that sort of thing. So very good question, Abby. So I prefer to get the decimal format because the decimal format takes into consideration all possible or the possible solutions to the thing. All right, very good, Yannick and Shadin. I heard you say you got that too. Jermaine and Andrew, Christoph, Exxon, Nestor. All right, very nice, very nice. All right, so I'm moving. So I'm going to be talking about some cases. There are 4 cases. 1, 2, 3, 4. There are 4 cases, and only these 4 cases will get in the exam. Now, guess what? Case 1 is what it is that we've been using. Case 1 is what it is that we've been using. So technically, there are 3 more cases that we need to look at. Some of the cases are a little bit more complex than others, but technically, that's what we're looking at. So a variable separable differential equation is one in which the equation can be written with all the terms of one variable on one side of the equation and the other term on the other side. So what I explained to you before, you know how I do my stuff. Even when I was in limits, I went through and told you some stuff first before I actually give you the rules. So I did mention, I don't know if anybody heard me say variable separable before in the explanations for the 6 examples that we looked at, but really and truly, case number 1 is what it is that you have been using. So let me just go through the cases. So case number 1, you get dy by dx is equal to fy, right? Similar to what it is that we've been doing. And then I'm putting this over 1 and I'm multiplying both sides. Now dy times 1 is dy and dx times fy. But sir, fy is not x? Of course. Fy is in x. The function in y, see here? This is going to be the function in y, and it's going to be in x. All right? So what we're doing here is we're going to have dy by dx times fy, and then now we are going to be looking at the all right. So what we're going to be doing now is looking at putting this y on this side and the x by itself, because remember it says a variable separable differential equation is one where all of the variables can be written on one side for the x and all the other variables can be written on the other side for y. Let me go through the last example we looked at. So we have this dy by dx is equal to all of this function in x. See it right here. So let me go to a spotlight so you can follow me. See it right here. So dy by dx is in that function in x. So when I put all of this over 1, it means that when I multiply dy by 1, I'm going to get dy and dx by all of this. I'm going to have my function in x. So on one side, I have my y, and on the other side, I have my x. So technically, I was able to separate my variables in x and y. But in other cases, it's going to be a little bit complex. So case number 1 follows this one, but there's a trick to case number 1. So yes, we have been looking at case number 1, but there's a slight difference with case number 1 that I'm going to be pointing out, which is why I came back to this example. And when we would have separated our dy or function in y compared to our function in x, then at that point in time, we're going to be integrating, because we're integrating this function that is only in y, and then we're integrating this function only in x. And of course, you know what the integration is. I won't go through that because you know how to integrate. And this is going to be my general solution. My general solution will be here. And for the particular solution, I just go ahead and just substitute accordingly, get the value of c, and then I will substitute into the general solution for c to get my particular solution. All right. So the difference with case number 1 here now, with the one that we looked at just now, in this one we have dy by dx is equal to f of y. Remember, the aim is to put all the function in x supposed to be together, the function in y supposed to be together, right? One variable on one side of the equation and the other terms on the other side. So if we don't get the x is on one side and the y is on one side, it doesn't make sense to start integrating because the question is going to be wrong. Yes, funny.
So the fy dx that is considered as x.
No, man, the fy dx is going to be a function in y. So work with me now. I'm coming there. Work with me. Sash, that was you a while ago talking?
Yes, sir.
I want to.
I message you since evening.
Oh yeah, true. Yeah. Um. mhm, We did. Mhm. All right. Just be safe. Mm. Let me just pause and say something here, please, guys. Um. It is also happening to me. Um. There is something in the air. I'm convinced that would want to give us some sort of flu-like symptoms, and just make sure that you're on your vitamin C, please. I'm going to ask you to ensure that you're on your vitamin C, that you're taking your necessary supplements to boost your immune system. Um, for me, this COVID virus is inching closer and closer. When people, close friends who either had COVID, died from COVID, and it is getting closer and closer. When I say closer and closer, I mean it's like you're on a football field and everybody's running up and down around the perimeter of the football field. And then after a while, it just like coming closer and closer to you, and you feel so claustrophobic. It is real, it is out there, and more people are getting it. And I have associates that are fully vaccinated that are contracting the virus, let alone those who are not vaccinated. So I beg of you, please don't play with it. If you feel funny, go and check it out. Go and check. A teacher friend of mine yesterday was at work, and she said to the principal, "I'm not feeling good. I don't know, I just don't feel good." Principal says, "Go and check it out." I'm good for left work, went to the hospital about 10:30 last night. I got a call. By 7 o'clock this morning, I got confirmation that the person has COVID. Please, as much as I'm speaking to you, I'm speaking to myself. Ensure that you're on your vitamins. Ensure that you're taking your supplements. Ensure that you social distance, you wear your mask, you sanitize. And know some of you have to go into physical work. Don't be a guard. But keep on the mask, work and say, sure, I'm a co-workers, them says never take off a mask. You don't know them. When it's lunchtime, nobody say you're sitting at the lunchroom and everybody give them idle talk and laugh and chat and they're eating lunch. Not do it. Time and tree out a door and go eat. Or if you drive, go sit in the car, go eat your food. All right? I'm just speaking it, please. It is real. It is very real. All right, with that said, let us go. So yes, so it is the case. The case that we looked at earlier is similar to this one. Well, it's similar to this one. It's also similar to this one. Sir, why is it similar? You notice what I'm doing here? I'm dividing all of what is over here by 1. All right. So let us go back to 1. So dy by dx is equal to f of y. So we have dy by dx with a function in y. With a function f in y. So we're going to divide it by 1. We're going to cross multiply. Remember, whenever you see two fractions separated by an equal sign, you cross multiply. So dy times 1 is going to be dy, and dx times f of y is going to be dx f of y. Now, you would recognize that in this case, this is my function in y, not a function in x. Not a function in x. Watch me. This one, when we would have multiplied, would have got f of x, because this would be a function in x, right? So this is another case by itself, all right? This one here is going to be a function in y. So look at what is going to happen. When we do that, we now need to get y by itself, x by itself. So if we divide both sides by y, we're going to have dy over fy is equal to dx. And then now, because when we look at it, we have all the y's together and all the x's together, we're just one x. Then we can go ahead and start the integration. Let me go again. So you're given the function dy by dx is equal to f of y. Dy by dx is equal to f of y. You're going to create two fractions, as we have been doing. You're going to be creating two fractions, as we have been doing. So you're going to have dy by dx is equal to f of y over 1. Always remember, whenever you have two fractions separated by an equal sign, you cross multiply. So dy times 1 is dy, and dx times f of y is going to be f of y dx. Watch me. What you're going to be doing now is to divide both. This on the left hand side has only y, the one you're safe. On the right hand side of the equal sign, you have both y and x, not safe. So you want to get rid of the y. So you're going to divide both sides by y, by f of y. And when I divide both sides by f of y, I'm going to get rid of this f of y on this side, and it's magically going to come on this side. So I'm going to have dy over f of y is equal to d of x. All right, that's case 1. Case 2, you can see the difference between case 1 and case 2. Case 1 is just one term in y only, in y only. Just like this one here is one term in x only. This one is one term in y only. All right, this one is a term in both x and y. This one is a term in both x and y. Okay. What we're going to be doing is to again create two fractions. And in creating two fractions, I'm going to divide the right hand side by 1. Now, once you have two fractions separated by an equal sign, you are going to cross multiply. Dy times 1 is dy, and dx times f of x g of y is going to be f of x g of y dx. This one is not bad also, because guess what? Y alone is on the left hand side, that is fine. But on the right hand side, I have x, and I have a y. I need to get rid of this y. So I'm going to divide both sides by g of y. And then I'm going to have dy over g of y is equal to f d of x. Now I have all the y's on one side, fine. All the x's on one side, fine. I can go ahead and integrate the function. All right? So in some questions, you're going to get the things that mix up. Like, one we did before, dy by dx is going to be equals to the function in x. Those are the examples we're working before. Case 1 is similar to what it is that we have been doing. But in this case, it's going to be fy. So you're going to divide both sides by f of y to get dy over f of y. In this here case, you have both f of x and g of y. So you have to end up dividing both sides by g of x, so that you have all the y's on one side and all the x's on one side. All right? Case number 4, and go ahead. You're unmuted just now. What question you have?
Oh, sir, the main thing will basically just try to get group everybody together then. So far it seems
Say it for me. Say it for me. The main thing is what?
we're just trying to group
No man, look at the screen, man.
variable separate.
Separable. Right.
Oh.
So we need to separate the variables first before we go ahead and start integrating. So yes, you are correct. So the
Okay,
main
alright.
aim is to put all the x's on one side and all the y's on one side before we integrate. So we are doing our variable separable. So the examples that we covered before was straightforward. Because even though we separated the variables, because we had dy by dx is equal to a function in x. On the left-hand side, we had both x and y there, dy over dx. On the left-hand side, we had something with both x and y here. So in order to separate the variable right here, this is the easiest method. This is the easiest method. In order to separate the variable, we're going to cross multiply. Now, when we cross multiply, bam, the variables already separate. The variables already separate. But in this your case now, when you cross multiply, you recognize that you have one more step to do. Case number 2, you have one more step to do. Case number 3, let me go to 3 first. You will see that case number 3 is pretty easy. Case number 4 is complex. Case number 4 come like COVID. Let's look at case number 3. You have a function dy by dx is equals to f of x over g of y. Low, sir. On the left-hand side, you have a function in both x and y, but on the right-hand side, you have a function in both x and y, again, similar to that of case number 2, Yaman. But in the differences, case number 2 is a multiplication. This one is a division. Oh, but I see something here, sir. All right. What's the thing? We don't have to divide by 1, sir, because we already have 2 fractions separated by an equal sign. Very good observation. So you just cross multiply. Dy by g of y is going to be equals to f of x times d of x. But sir, this done because all the y's are on one side and all the x's are on one side. Very good. Let us look at case number 4. But sir, case 4 and case 3 are not the same something. Oh no, sir. Because in case 3, you have f of x up on top and g of y at the bottom. In case number 4, it reverse. G of y on top and f of x at the bottom. All right, don't blink. This one is tricky, guys. Don't blink. This one here is the hardest. And I need to show you the general. All of these are general forms, you know. All of these are general forms. Before we move into 1 or 2 examples that I generated for you. Let's go. Dy by dx is equals to g of y over f of x. We already have 2 fractions separated by an equal sign, so the rule is to cross multiply. We can't change the rule there. We have cross multiply. So dy times f of x is going to be f of x dy. We normally write the dy's last and the dx last. If you notice, we normally write it last. Don't write it in front, write it last. Eh? And then d of x times g of y is going to be g of y d of x. G of y d of x. Why, sir? We have on the left-hand side both x and y, and the right-hand side both x and y. But me see what happened here, sir? That f of x if we go over here so, and the g of y if we come over here so. Very good. So look at what is happening. I am going to be dividing both sides, and I want you to pay attention to this. I'm going to be dividing because I recognize that what is over on the left-hand side should go over on the right-hand side, and what is on the right-hand side should go over the left-hand side. I'm going to divide both sides by both f of x and g of y. Both f of x and g of y. This is, I believe, is the simplest way I could explain it without, you know, confusing you so much. I'm dividing both sides by f of x, g of y. When you have it like this, where both of them on the side here, on the side here, we're dividing both sides by what it is that you need to flip over. So see here, f of x, g of y. F of x, g of y. You're dividing both sides by the same thing. Now, when you divide both sides by the same thing, the f of x will cancel. So what you're going to have is dy over g of y, which is this, same thing. This is same thing as dy over g of y. And the g of y will cancel. So you're going to have d of x over f of y, over f of x, which is this. So now you have a function in y only and a function in x only. You have to go and do this integration. You have to go and do this integration. All right? When you reach this level of integration, now it brings in the natural logarithm functions. And this is what a lot of students get mixed up with. All right? So those are the 4 cases. What I'm going to do is I'm projecting the 4 cases on screen. I have gone through all 4 of them and projecting it on screen. giving you an opportunity to look at them. I'm going to give you 5 minutes. I'm not disturbing you. I'm just going to give you some minutes to just look at them and see if you can just play through them again in your headspace before I continue. So take your time, starting now.
Sir, scroll back up a bit. Let me write down the topic, please.
Right there?
Yes, sir.
Okay.
Right, you can go back up. Thank you.
Okay.
Sir, for case 4, is there a reason why you put it over 1, or is just to give us a different look? Just see.
Right. Why put this one here?
Yeah.
Yeah. So yeah. So what? Right. So if you like, I had this one here as dy over g of x.
Yeah.
I could have this as
The 1.
1 over g. Right.
Okay.
So this piece here is the same as this piece here. You get me?
Yes, sir. That is why I asked if it is just to
Yeah.
give
It's a different perspective of how I can write it. Yes.
Okay.
Man. Obviously. Okay, asking again, how are we?
Okay, so far.
I'll take another 2 or 3 minutes just to look up at the rules, because following this will be some examples. And I can't tell you, the question not going to come and say using case 1 or case 2 or case 3 or case 4. You will now need to know which of the cases to.
Sorry, you can go back over case 4.
I have no problem. All right, so case 4, you have dy by dx is given. In case 3 and case 4 are somewhat related. Case 3 and case 4, the question was already given in fractional form. So because it's given in fractional form, there is no need for you to divide by 1 to make it a fraction. It is already a fraction. Always
Yes, sir.
remember when you have two fractions separated by an equal sign, the cross multiply every single time. So when the cross multiply, you're going to have dy times f of x is going to give you f of x dy, which is here. And when you have dx times g of y, you're going to have g of y d of x, which is here. Get that so far?
Yes, sir.
All right, good. And then now, you recognize when you look at that line that you have a function in x with respect to y and a function in y with respect to x. But I can't have a function in x with respect to y to integrate. That just don't work. Don't work. And I can't have a function in y to integrate with respect to x. That can't work. It's just like you can't put 87 in a diesel car or a diesel in a motor car. It's going to mash up something. Something that's not going to go right. Okay. So with that said, I know that I need to separate these two variables, and because my function is in x and my function is in y here, I'm going to divide both sides by the function in both x and y. What I'm saying to you is that these two need to flip around. This f of x needs to go over here, so and this needs to come over here. So when you say that they need to flip around like that, just divide both sides by the two functions. See, Teresa? The two functions.
Okay.
In this case, you never had to divide both sides by both functions because one of the functions was in its correct position. It's just the other function that is not in the correct position. So the function that is not in its correct position, you just divide by that. But in case 4, both functions are out of place. This over here and this will come over here. So dividing both sides by f of x g of y. And when you do that, my f of x's will cancel, leaving just dy and gy, which is what I want. And my gy's will cancel, leaving just dx and my f of x, which is what I want. So now, as Yannick asked the question, really and truly, what I have, this dy over gy are the same thing like this, 1 over gy dy. Same thing. I just choose to separate it this way. All right,
Okay.
same difference. And of course, I have my 1 over f of x. All right, and yeah, that's it.
Okay.
All right, no problem. All right, I think that's enough time. Let us run through a question. Lord have mercy, sir. Let's see what you're talking about. So we need to find the general solution of the differential equation. Y dy by dx is equal to x. Okay, sir. All right. What's the first thing to do? When you get the question, what's the first thing to do?
Cross multiply.
Fraction.
Before you cross multiply, you have to do something first. Yes, Yannick, I hear you. What, Yannick?
One
You have
another
to
x.
get the fraction, both sides.
How do I get that?
by putting the side that is not a fraction over 1.
Very good. Which is the one is x. So I'm going to put the x over 1. All right. So look at what I'm doing. So I am putting the x over 1. All right. I show you that I put in the y over 1 also, but this y, I'm showing that I put in the y over 1 for you to recognize that this y here is actually going with the dy. This y does not relate to this dx. You know. This y is automatically, when you see y like that, this y is automatically married to the dy. So I put it over 1 to show you that union. So what it is that I have is going to be y over 1 dy by dx is equal to x over 1. So this is going to imply now that my y that is married to my dy is going to be y dy over dx. See here? Y dy over dx is equal to x over 1. So now we have two fractions separated by equal sign. We can cross multiply. When we cross multiply, we're going to say y dy times 1 is y dy. And x times dx is going to be x dx. But what on, sir? We separate it? Yes or no? Did we separate it?
Yes, sir.
We did. We did. So hold on, I just space it out. Yes, we did. So this one is really not bad. This one is really not bad. So what I want you to do for me is to finish off this question for me. Finish off that question. You can start writing it from there. I've explained what it is that we've done right here. The aim is, as Lexon asks, sir, I've seen a trend. Is it to just get all the x's and y's on one side? Yes, ma'am. So now that you have that, why I'm asking you to integrate without projecting it is to give you some more practice on your integration. And then I'll project what it is that I have. So remember, if you're not given fractions on both sides, you need to make one of the sides fractions. Then the next step is going to be cross multiplication. If you're given the fractions, just go ahead and just do the cross multiplication. If you're given a fraction, just go ahead and just do the cross multiplication. All right? And then when you do that, you'll see if your variables have been separated. Once the variables are separated, meaning you have the x's alone on one side and the y's alone on one side, start the integration. Do not start the integration before you're seeing that all the x's on one side, all the y's on one side. You recognize that next week is our last teaching week, right? So technically I have 2 more classes with you, Tuesday and Thursday. And the final week of the 24th is going to be your personal revision week. And then the following week, the 31st of January through to the 11th of February is when your exams will take place. I'm feeling something in my spirit. I need to share it with you. This topic is a must-have on the paper. In the last couple of semesters that I've been doing Calculus 1 and 2, I'm seeing where they have differential equations. It's a must-have. Your stationary point is also a must-have. Your stationary point is a must-have. Your implicit differentiation, they like to give it, and I've done implicit differentiation with you. I don't know if they will give you any limits question per se. And if they do, it's mainly in the multiple choice. They may give you a limits question, you know. They may even give you one with L'Hopital's rule. They may give you one with L'Hopital's rule, and they also may give you a piecewise function question. I'm not worried about those because those we did already. I'm not worried about those. But implicit differentiation, I'm feeling it. Implicit differentiation, stationary point, the topic here. And let me tell you how actually it may come. They may give you 2 of these questions, 2 5-mark questions on this for 10 marks. And they may give you an implicit differentiation for another 10 marks. That's a 20 marks. They may give you a stationary point question for another 20 marks. So you have 1 more question to work with. And that one question could be anything from, what do you call it, L'Hopital's rule, to a one question to differentiate, to a one question to integrate, to a one question on L'Hopital's rule, you know, and any form of integration, either the substitution method that we looked at before, you know, the exponential function, the logarithmic function, anything like that. So that third question is what is a little bit fuzzy to me, and incidentally, I've not seen the paper, so I don't want anybody to take what I'm saying, you know, answer. But sir, you said that this was going to come. I'm not saying that. I'm just telling what I feel. I know this topic is a must-have. I know stationary point is a must-have. I know implicit differentiation is normally on the paper. You'll get a multiple of differentiation and integration questions. And you have many types. Integration could be exponential, logarithmic, substitution, indefinite, definite. The interview, even the one that the diagram, the drawn diagram for you to area under the curve that we've done. Pretty much, I am literally wrapping the syllabus now. So anything that's thrown at you, you should be able to answer it. I know I have L'Hopital's to go through with you. And I have L'Hopital's to go through with you. I did some preparations on L'Hopital's that I have here for you. I have L'Hopital's to go through here. Don't want to do it just yet, but I have it here so you don't have to worry. I did maybe 2 or 3 questions on L'Hopital's. L'Hopital's is pretty easy. We've done most of it already, so that's why I'm leaving it for last. I want to get some of the big boys out of the way. And then, yeah, so this is it, because after this, then this is the end of this. Exponential functions. We have done this before. I just put it back here because this is where it's supposed to be. And the differentiation of the explicit and implicit exponential function, right? So I've done explicit and implicit functions with you already. And especially the implicit one, now what I need to do is the implicit integration. Sorry, the implicit exponential. So, and exponential and logarithmic. So here goes one with the exponential and an example with the exponential, and I have an example with the logarithmic. It really doesn't get any more difficult than the ones that we have done before. It's just that the exponential, the implicit one, is going to be something that includes the logarithmic function, and you know how to integrate a logarithmic function. Integral of ln is 1 over x, and you know how to integrate an exponential function. The integral of the exponential function is the exponential function itself, because we've done all that differentiation. We've done implicit differentiation, so this here is not bad. What's the point I'm making? This topic, the differentiation of the explicit and implicit exponential and logarithmic functions, not bad. We've already done this topic before. I want to put it in the correct position because I had it under integration, but it is supposed to be under this topic, so I just transfer it here. We've done that before. And this is my differential equations, and then I'm going to have L'Hopital's rule. So when I'm finished with L'Hopital's rule and those 2 things that I just showed you, then I'm pretty much finished, and to move into something else. All right, sorry to disturb you. I'll give you another minute so you can finish up. Anybody finish, by the way? All right, I was talking, so go ahead and finish. Sorry about that. All right, so I'm answering the question one more time. Are you finished?
Sorry, I'm kind of stuck, so I'm just a wait.
We'll continue if you.
Oh, so you wouldn't have anything to the y.
I wouldn't have what?
No, it's the y. I wasn't sure what to do with it.
All right, so let me explain here. Did I explain what I was doing? Remember, when I was doing different integration. Remember, I was doing integration with you. I was saying to you that one c plus another c plus another c is the same c. Anybody remember that one?
Yeah, yeah.
All right, cool. So let's go now. So we would have gotten to this point, and then we're going to be integrating here. The integral of y with respect to y is going to be y squared over 2 is equals to x squared over 2 plus c. And what I'm going to be doing is multiplying by throughout by 2, the LCM by 2. I'm going to multiply throughout the equation by 2, which is the LCM. And when I multiply by 2, I'm going to, these two cancel out beside the y. So is this one. And this one now becomes 2 times c. But 2c is the same thing as c. 1c, 2c is still a constant. All right? So I'm going to have y squared is equal to x squared plus c, which is this. And it did say general solution, so we don't have anything else to do with that. So that's the end of it.
Go it again, sir, one more time.
Yeah, one more time.
As your last one again.
All right, then.
That's
So
what choose to go. Yeah.
you're good to write here, don't?
Yeah.
All right, good. And when when we integrate, we're going to have y squared over 2, which is this. And then when we integrate x, we're going to get x squared over 2 plus our c. So why c again? Because it's an indefinite integral, eh? So this is my integration. The question is finished here, but I'm just fixing it up. And fixing it up makes a big difference. Where you do get marked for fixing up. Watch happen now. The LCM here is 2. The LCM on this side of the equation is 2. The LCM on the other side of the equation is 2. So what I'm going to be doing is to multiply throughout the equation by the LCM, which is equal to 2. Then, sir, the LCM was equal to 3. Did I multiply by 2? No. You multiply by 3. All right, sir. What if on the...
All right, sir, before you move past the line there.
Mhm.
All right, so I know with the dx, it becomes the plus c, right?
Mhm.
The dy becomes a y.
I'm integrating with respect to y. No. No. No.
But, yeah, that's what's confusing me.
No, man. When I integrate y, we get... No, y squared over 2.
Yeah, but what happens to that dy?
It's fine. Question.
Because usually up here, it usually becomes y.
Here, so?
Yeah.
No, because we're integrating. No, because there's a 1 right here, Yanni. Remember when we're integrating, there we don't say 1 dy, we just say dy.
Sir. Okay. All right, you can continue, sir.
All right, then cool. That's why I went back up. All right. And then no, what I thought you were gonna ask me is why I don't have a c on the other side. But remember, in this here case, we just put the c on one side of the equation because we're letting y to be equals to something. Y is going to be equals to something. So normally when you get your question, y is equals to all of that plus c. All right. So y is normally equal to this. So we don't have a plus c over here. So this is my particular solution. So you don't have a c over here. Y my independent variable is going to be equal to my dependent variable. So my dependent variable is on one side and my independent variable is on the other side. I'm not going to mix up anything with that. That is just so it goes. Y is equals to the function, right? So that's why when we integrate, we don't have a plus c over the y side, and we won't put a plus c over the y side. we want to put a plus C over the x side because the x is going to be the independent variable. Same thing right here, so I won't put a C right here, so not here, so here, so.
Sir, it look well different when you like it. Our brains process, let me not say it look different. Our brains process it
Process it
different
differently.
when it's just a one there that would do right versus when you get
Right.
all a scared or
Other thing.
a
Fair enough. Fair enough. Fair enough. All right, no. And then when I have from that line, I'm going to multiply through by the LCM. So what I was going to say, sir, what if this were 2? But here says 3. What would be the LCM?
6.
6. So what would you multiply throughout the equation by?
6.
Simple. 6. Yeah. So we just do that so that we can get rid of the fraction. That's all we're doing. We're doing it so that we can get rid of the fraction. All right. So having done that, I will do our cancellation here. The 2's will cancel, leaving y squared. The 2 again will cancel from this, leaving my x squares. And then I'm going to have 2 times c. But remember, when we did our integration, and I said to you that when you're integrating something that looks like a chain, what you're actually doing, we can do it one shot. Matter of fact, I think Yannick was the one who said, but sir, you know, can do this in a one line. Duh, that is the expectation. To do it in one line. Then sir, make it do it in an 8 lines the last time because I was teaching you the topic. I was teaching you the topic and I want to teach you. And then when I teach you, you understand what you're doing, then you can go ahead and look at it. Now, what I have done with you, and I remember using a whole lot of colors that night, is to integrate individual terms. So if I gave you the integral of x squared plus c, it will be the integral of x squared dx plus the integral of c dx. All right, and so that is important. And then know all of those plus c's that you'll get will give you one c because you recognize, and if you don't believe me, you recognize when we integrate everything in one shot, how much c we get at the one shot?
1.
1 c we get at the one shot, right? But when we integrate it little by little by little, we're going to get multiple c's. You know, what multiple c's? A constant is a constant. Is a constant. All right? A constant is a constant is a constant. Okay. Here goes a second question. But sir, we did that question a while ago, did we?
No, it was the other way around.
Yes, it was the other way around. All right. You notice that already. Say, when we look at case number 3 and case number 4, when it is the other way around, one of them was troublesome. One of them was troublesome. Case 4 was troublesome. Case 3 was an easy fix. All right. I'm giving a couple minutes. I want to see how far you can go with the question. And then I'll come to your rescue. Please, wherever you're stuck, just unmute and tell me. I'm going to mute. I'm right here, but I'm muting. And wherever you're stuck, just let me know. Sir, I'm stuck. Sash, how are you? How are you now? Feeling any better? Oh no, she's not here. Sasha Boo? Oh no, she's gone. Message her. Message her.
So you can scroll up back to the cases.
Sir, this is not working.
I was just about to say, Keith, hear from nobody, and then I hear it coming.
I
All
missed out.
right.
Well, wait.
You come
Oh
in
no,
for
but I told it to say something to me.
Oh,
I am here waiting on you.
yeah,
All
no,
right.
yeah, expect us to get stuck. So
Right, I expect you to get stuck, All right.
Sir, me say long time crazy glue, but
Oh, I didn't hear that. Oh, I didn't hear that because you can get something looking like let me not tell
that
you.
disappears in that PS4. Let's start.
Right. You remember I did say to you that
is it a case 4? Yes, it did.
right. I did that. So let's go now. Well, okay. So the first thing is that we're going to put our x over 1, y over 1. Like so. Then we're gonna cross multiply, we're gonna get x dy is equal to y dx. Oh geez, but sir, this is exactly what you're talking about in case number 4, where you have the x with the dy and the y with the dx. Then sir, what we do? Remember, sir, so you can divide both sides by xy. You can divide both sides by xy because you have the y with the x and the x with the y. So when you see that, that's to divide both sides by xy. Oh, see it right, there's a circle truth. And when you divide both sides by the xy, the x will cancel the x, so you're going to be left with 1 over y dy, and the y will cancel the y, we're going to have 1 over x dx. See it here, so? Right here, so. See it here now, unique. dy over y implies 1 over y dy, and dx over x implies 1 over x dx, all right? Same difference. I'm showing you the both conventions. So now I have my y's on one side and my x on one side. Then I'm going to integrate. Let me know if you got up to this point.
Yes, sir.
Right, here's some stuck, sir.
Yeah, yes, sir.
And that's exactly where I expect you to stop.
That
When
is
you integrate 1 over y, what do you get?
0 may I get, sir?
You
Which is
can't get 0. Remember, I said to you when we're doing the integration, if you put y to the minus 1, remember you're adding 1 to the power. So anytime you have y raised to the negative 1, you can't use that. You have to know use the ln function.
yeah, that is what I was trying to remember. May I skip through search? I remember which one of them
Yay.
was
Let me
used
see if I can.
so I just stop.
Let me see if I can refresh your memory. That's why I tell you, I expect you to be stuck, because oh no. That's the one I
The thing
want.
is, I was looking at the exponential one. I'm like, no, this is not it.
Right. Hold on, I'm just trying to refresh your memory. Boy, that's something else I plan for open to see. Jesus. And guess what? After it took so long, is a wrong document I open. Father friend. Alright, watch me. Remember, I said to you, the integral of x to the minus 1. Integration, you add 1 to the power divided by the new power. We can add 1 to negative 1 because we have to get 0. So that question cannot be done using this. We have to go use this ln, the absolute value of x. And why the absolute value of x, sir? Because we can't take the logarithm of our negative number. So remember, whenever you have, and you have these notes already, whenever you have 1 over y, 1 over x, it's going to be ln y or ln x, because you can't, if you convert it to x to the minus 1, and you're going to add 1 to the power, you add 1 to the power, you're going to get 0. And you cannot divide by 0 because you have to divide by the new power. You can't divide by 0. It is illegal to divide by 2. It doesn't exist. So understand. So you have to know using the ln function. You have to use the ln function. We need to remember that. Okay, let's go back. I expected you to forget still, that's why I. Oh Lord, where am I? What am I teaching you? Oh Lord. Oh, applications of differentiation. Sorry. No. Where am I, guys? Hold on.
Variable
Yeah, it's this one. All right, so let me just be excited a little. Look what you did and it's all along. I know this setting is here. Relax this way. Sure. All right, so let's go. All right, hold on there. Let's just do this side too. Oh, my father friend. All right, now, right. So this is what is happening. Don't read ahead, man. Just work with me. I didn't want you to see all of that. Just no, but that's not the question. Yeah, that's the question. All right. So don't read ahead. Just wait until I go through the explanation. Where am I? Good. So you're integrating here. So now, remember now, having refreshed your memory on the stuff, the integral of 1 over y dy is going to be ln y. The integral of 1 over y dy is going to be ln y. And the integral of 1 over x dx is going to be ln x plus c. But you notice I put the absolute value side. So listen to what I wrote. We take the absolute value of x since we cannot find the logarithm of a negative number. You know this. You know this. So why then change the constant c to ln k? This was done since the other terms are in ln. Yeah? Put it this way. Because I know I will give you one to do on your own and I want to see how well you can do that. Put it this way. So you are traveling and you have a credit card, you have a debit card, and you have some cash. But in your pocket, you find quite a bit of Jamaican dollars. And that's quite a bit of Jamaican dollars. Could be 30, 40, 50,000 worth of Jamaican dollars. And you say to yourself, geez, I can't even find a machine now to go deposit to the machine so I can swipe it on my card whenever I reach where I'm going. And sometimes that happens to me when I'm traveling, right? And sometimes I don't have time to stop off at like say a Western Union or a bank to go and change out the Jamaican to foreign exchange. Besides, most times I'm doing is either early morning flight or a very late night flight where me now stop on the machine and kind of night or the time of morning there. So you reach, and when you reach at the airport, they may say to you that foreign exchange, sir. What's your destination? You say, US. Foreign exchange, and look at the rate and say, no, sir, I'm not changing that. That's too little money. No, sir, that's all right. And you catch a foreign now. And when you catch a foreign, you recognize, say, boy, say, the money run out and I have a 15,000 or 50,000 Jamaican dollars, and you may find one of those cambios that you can go ahead and, or even a Western Union, that you can go ahead and change out the Jamaican dollars to US dollars. What's the point I'm making with that? You're in an environment, the US, where they have both US and Jamaican currency, but you really don't want the Jamaican currency because the Jamaican currency can't use there unless you have it on a card and then you convert it. It's the same thing right here. So you're in an environment, the US, LNY, LN absolute value of Y, LN absolute value of X. But now you will have some Jamaican currency. This Jamaican currency can't do nothing. Chances are you walk up on with the Jamaican currency and you're gonna lose it. Or yeah, because and the Jamaican currency is so bulky already. So you don't need it. So you may say, you know what? I'm gonna convert this here, man, because we're gonna need some extra funds. So we can convert it. So because we did indices and logarithms, and because we know how to combine and to convert our stuff, we're gonna just combine it. So what I'm saying to you, my constant C here, I'm going to change to LNK, and because don't since the other terms are in LN, all right? I am doing it because I am in the United States of America and I don't need a Jamaican dollar because the Jamaican dollar is not going to suit me well. And I'm in the States not for 1 week where I can say, try me soon go home back. I'm there for 1 month. But I might keep the Jamaican dollars, I might run out of cash. So I'm converting everything there. So that's exactly what I'm doing. So LNK is going to be equal to C. ln of a constant. So in this case, we're not going to say LNC, right? K is going to be the constant in this case. So we're going to call it LNK. So LNK is going to be equal to C. We can't call it C because it's already C and we don't want to confuse the C's. So we're going to say, you know what, LNK. So our constant C, we're going to call LNK. Sorry, if I leave it like that, I'll get full marks. They may ask you to carry it down to a particular point. They may ask you to prove that this is equal to this. In order to prove it, you have to go carry it all the way down until you can't simplify it any further. The differential equation is finished now. It's a simplification we're talking about now. So I need to spend some time with you with the simplification. Look at where the differentiation, the differential equation ends right here. So differential equation ends right here. What we're doing now is just to fix it up, neatify it. So watch me now. So I'm going to convert this C into LNK. So now I have LNY, absolute value of Y, plus the absolute value of X, plus LNK. Now recall, there's a law in logarithms that says when I'm adding my logs, I'm going to multiply. The law says log to the base A of B plus log to the base A of C is going to be equals to log to the base A of B times C. So in logarithms, when we add, we multiply. In logarithms, when we subtract, we divide. Let's go again. Log to the base A of B plus log to the base A of C is equals to log to the base A of B times C. In logarithms, when we add, we multiply. You recognize that we're in the same base, log to the base A, log to the base A, log to the base A. And when we have an addition there, it's going to become a multiplication. So log to the base A of B plus log to the base A of C is going to be equal to log to the base A of B times C. B times C. Now, it means that because I'm in logs and I have an addition sign right here, this addition sign is going to be converted to a multiplication sign. So look at what I have now. Taking the anti-logarithm, so I'm going to have all of that, and then taking the anti-logarithm on both sides, meaning that I'm dropping the logs. So I'm going to have y is equal to kx. So this is what it works out to be. So I have these two. I'm taking the anti-log. I'm dropping both sides, the logarithm on both sides. K times x is kx. And dropping the log, so I'm going to have y. So my differential equation comes down to y equals kx. Do me a favor. I want to get up to here. So I want to know this part now. I want to know this part. I want you to take some minutes and read through this part for me here. And when you read through it, then you can come to me and ask me some questions. But read through it first yourself. On the mark, hit set, go. Start from here. Obviously, are we good? Can you talk to me more? No answer the same when it comes to me. Good morning. You need more time to reflect it?
Sir, I don't know about anybody else, but ready when you are.
I just want one person to tell me them ready, you know, because I've been ready. All right, watch me now. Try that one for me, please. Try that one for me. Go as far as you can get to. Wherever you're stuck, just stop. Let me know. Don't just sit down here. Go as far as you can. Stop. Let me know so we can have a conversation about it. Start, please.
I mean that, sir. I mean that.
All right. Let me know. Were you able to separate the variables?
But do something like that, sir.
You say,
Good and why the common, sir.
All right. I have that. I have. Oh, this is which case is this one? Case number?
Example, wait, case, this is case 4.
Case 4, correct, correcto. So remember now, so you have x with the y and you have the y with the x. So you have to multiply both sides by this and this together. Remember that? Which is this. When I cancel that, I'm gonna have 1 over y. I'm gonna have this. Did you get that?
yeah, we have x to the third.
X to the third.
In y to the third. I'm going to get y times y plus y.
No, I'm gonna reach the
X squared plus y.
No, I'm gonna reach the integration part. I want to see how well they do with the separation of the variables.
Oh.
All right, let's go. Let's go. So this is my question. Again, I'm putting this over 1, like so. And of course, my x is going to be over 1. So I have two fractions separated by an equal sign. I'm going to cross multiply. X dy times 1 is x dy. Y times y plus 1 times dx is going to be y times y plus 1 times dx. And if you look at this, you recognize clearly that this is case number 4. Case number 4 said that I have my x with the y and my y with the x. I have to separate it. How I separate it with case number 4? I'm going to divide both sides by this times all of this. See here? X times y plus 1 to both sides. Then I'm able to cancel out the x's and I'm able to cancel out the y times y plus 1. So I'm going to be left with 1 over y times y plus 1 dy is equals to 1 over x times dx. Come on. Right here. So now I'm able to separate my variables. So having separated my variables, all y's on the left hand side, all x's on the right hand side. Yes, Lexa.
Sir, I kind of do something like a different. I know if it really affect nothing. What I did, I end up have 1 over y squared plus y dy equal 1 over x dx.
Same difference. Same difference.
All right,
Same
sir.
difference. Because when you distribute the y inside of the parentheses, you get y squared plus 1. Same difference. All right, so let's go now. So now I can go ahead and integrate. All right, and then now, this is where I had a challenge. This is where I have a challenge. When I was doing this, you see, so my aim is that I wanted you to get up to this stage. I really wanted you to get up to this stage, being able to separate the variables. But I don't know if this is an error based on the curriculum. Based on the curriculum, I don't know if this is an error based on the curriculum. But in order for me to have done this one, I had to use partial fractions. Anybody did partial fractions in any of the other courses?
The what?
Partial fractions. This is a topic in itself. It's a whole different topic in itself. Partial fraction. You did that before? Never. So this is a challenge. This is a challenge I have because These cases are on your syllabus. And this particular question, remember we did a question before with case number 4, and it never involved this piece. This piece, meaning this piece here, the multiplication, is what I'm going to show you this. I'm going to finish a question with but I'm just going to tell you what I'm not seeing on the syllabus. So looking on the syllabus, I'm not seeing partial fractions, and I think I know what your syllabus looks like. You do foundation concepts 1, 2, 3. If you don't have CSET math, then you do discrete math, prob stats, then calculus 1. All right. Now, the question before that we used, this question before, you notice that there was no multiplication down here, so it was just a single digit in the denominator. That's case number 4. But this one here, we end up with a multiplication in the denominator here. That multiplication in the denominator is going to be, will have to be used with partial fractions. So I'm gonna finish a question. I'm gonna finish a question and just explain to you what it looks like. I'm gonna finish a question, explain to you what it looks like. But I'm also going to say to you that I don't expect them to give you one where it is that you have a multiplication in the denominator. Why, sir? Because I'm not seeing partial fractions on your syllabus or any of the syllabuses that you've used. And if you don't know how to solve the questions using partial fractions, you're going to be in problems. Is having written this question and working it out, I realized this and I said, you know what, I'm going to let it stay and I'm going to highlight it. Now you don't have to worry, because if you go into the exam and I see something like this and I'm not seeing it on the syllabus, I will personally write to CCCJ to say to them that I'm not seeing, help me to find where partial fractions is on the curriculum. And once they can confirm that it's not there for me, and I've looked for it several times incidentally, and you too can look for it to see if you see any partial fractions. You will have to scrap the question or give them up. And trust me, I am notorious for that. When it comes down to my students, the college knows me. I'm notorious about it. What's this? Take a rank on the exam? Don't do it near my students. I'm notorious for that. So you don't have to worry about that. But anyway, let us continue. It says, please note that the signs that separate the two terms is negative. Comes negative. So that's all I'm going to say to you in red. That the sign that separate these two terms is going to be negative. Sir, how you get the negative sign there? It is going to be a partial fraction. I'll have to solve it using partial fractions. Partial fractions is what I'm not seeing on the syllabus. But for now, just take it as it is here, sir, because I want to finish this question to show you what it looks like. I expect case number 4 to be in the previous example that we did, and not this one here. All right. So in that regard, we're going to have all of that. The right hand side is easy to integrate, because we integrate 1 over x is going to be ln x plus c. And of course, we always use the absolute value of x, as I told you before. So this integral here is going to be ln y, absolute value of y, minus is going to be the absolute ln the absolute value of y plus 1 is equals to ln 1 over absolute value of x plus c. So once you get to here, this line here, the integration is going to be very easy, because when you integrate 1 over the function, it's going to be ln of the function. And of course, remember, we're using the absolute value. All right. Now, what does that mean here now? Again, similar to what it is that we used before. C, because everything is in ln, we're just going to call the other element ln k. So I'm going to let C to be equal to ln k. So I'm going to have ln absolute value of y minus ln the absolute value of y plus 1 is equals to ln the absolute value of x plus ln the absolute ln k. Now, recall, log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. But sir, you're not multiplying right here, so I mean, you're not adding right here, so you're subtracting, yeah. But I want to multiply, add, so we end up multiplying, right? So when we're adding logs, we multiply. But watch this now. Log to the base a of b minus log to the base a of c is going to be equal to log to the base a of b divided by c. See here. Log to the base a of b minus log to the base a of c is going to be equal to log to the base a of b divided by c. When we subtract logs, we divide. I told you this from case number 4 in the previous question. So let me go through that slowly again. Log to the base A of B plus log to the base A of C is equal to log to the base A of B times C. Log to the base A of B minus log to the base A of C is equal to log to the base A of B over C. You know what we divide? We're not dividing log to the base A of B divided by log to the base A of C, We're not do that. We are saying log to the base A of B, log to the base A of B over C. Log to the base A of B over C. Oh, so there's something that I need to include on the review of the syllabus. Because I had to use this for the previous example, so I need to put in some levels of logarithms in it. All right, let's go. So this now is going to become ln y over y plus 1 is equal to ln kx. See? Ln y over y plus 1 is equal to ln kx. Sir, how you get that? See it up here, man. Look, man, see this up. Log to the base of b plus log to the base of c is equal to log to the base of b times c. And remember now, log to the base of b minus log to the base of c is equal to log to the base a of b over c. So see this up. When you subtract the divide, so this is going to be log y over y plus 1. Teacher, ln y over y plus 1. And because I'm adding here, it's going to be ln x times k, k times x. So here the constant coming forward. So k times x, teacher, so yeah, man. And then I can take the antilog of both sides. So we have y over y plus 1 equal kx. So the inverse and the antilog of both sides, I'm going to get that over that. But the question did the question ever ask about the general solution? I mean, the particular solution, did it? No.
No, sir.
Right. So I am complicating it now and saying that if the answer for the general solution, given y equals 1 when x equals 1, not a problem. We just substitute. So when y equals 1, 1 over 1 plus 1 is equal to k times 1. 1 over 1 plus 1 is going to be a half, and k times 1 is k. So a half equals k. A half is equal to k. So k is equal to a half. So if we were to do this, now we're going to get that. So we found the value of k. All right. So the question is still solvable, right? Except that you would need to first know how to write it in partial fractions. So I'm saying again, what it is that we have done there is fine to show you how to go about doing the solution to the question. My only concern is that you're not introduced or required to do partial fractions, and in order for me to have gotten that section there, I had to use partial fractions in order to separate it as 1 over y minus 1 over y plus 1. But as I said before, partial fractions not on the syllabus. I don't expect them to give you that. I don't expect when it is that you separate your variables, you're going to have a multiple in the denominator. Once it is that you have a multiple in the denominator, you have to use partial fractions. If you have just a linear function inside there, you're fine. So if you had only y plus 1, you're fine. But anyhow the values get greater than y, meaning like y squared, like what Lexan's input. Lexan's input y squared plus y. Then no, that's a partial fraction. Then we'll have a problem because that's not coming. But outside of that, you're good to go. All right. This is now 9:36. Go ahead.
Sir, so what you say we must do if we see that on the test?
If you see it on the test, go right up to separating the variables. Go right up to doing the integration. So you're going to go right up to separating the variables right here. So you're going to have a problem integrating this piece. But go ahead and integrate this piece and just stop, because we don't do partial fractions. And I'm not going to be teaching the partial fractions.
Okay.
I'm very sorry. I'm not teaching the partial fractions. It's not on the syllabus. We're not teach it. All right? And then don't allow me to fight my battle. Because if it's a 10 marker and up here to come to 5 marks, best believe they're going to get the other 5 marks, or them get mark the question out of 5. All right? So trust me. When I say trust me on that. All right. Okay, it's now 9:37. I'm going to give you one more question, and we'll finish with that question. We just call it a night. But before I do that, though, remember I have L'Hopital's rule to look at. I have the implicit functions for the exponential and the logarithmic ones to look at, and those two would cause me to finish the curriculum. I need to look at some graphs with you. Yeah, man, I should be able to finish off next week because those two, you know, I'm observing something from January 3 when we met first that I'm seeing at most, it's 9 of us. Sash was with us, but she had to go. The most I saw in class, Thursday, we had 13, including myself. And I think I was logged into, today's Thursday, no, Tuesday. And I was logged into 2 devices. So that means there are 11 of you in class. And I'm watching what is happening. I guess people are watching the recordings. I'm hoping that they're watching the recordings and listening to what it is that I'm saying in the recordings, because I still post the recording. But it's not a good look. I am not pleased when students don't turn up for class and students are not mannered enough to say, sir, this is the challenge that I'm facing. All right. And I'm not reteaching. There are 2 students who sent me a message. 2 students sent me a message to explain why they're not in class. But you know, I'm going to say to you, I'm not coming to class. I was a little annoyed in the first week. I noticed on Tuesday, I didn't say anything, and tonight I'm not saying anything. I'm just, you know, expressing that point. Because when that exam paper comes, and that paper is marked, those grades will indicate those students who were astute enough for classes. You cannot, when you miss class, you miss instruction. The recordings are good, but there's nothing like getting the classes live. Because when you watch a question, and especially students in the classroom, ask questions, it can be lost. I know the ones who are coming to my class. I know the ones who are coming to my class. And I've been watching closely for the ones who are not going to come. And so we come next week for the final week. Please pass on a message to them. With the exception of those 2 students who sent me a message. Nobody can say, sir, I didn't on that. Can you go? I'm not doing it. Call me hard, call me wicked. That's fine. I know the complete syllabus for my students who are in front of me. I'm not going to leave on an incomplete syllabus to go over something that I've taught for students who did not turn up for class. Negative. So the plan is, on Tuesday, God's willing, I have 2 hours. You notice the exponential function I did, the implicit functions for the logarithmic and the exponential one. I just did one example each, because when you say maybe it's really not difficult. It's like the same something that we do. It's not difficult. This one I'm giving you many examples because it's the other one not difficult. Trust me on that. And L'Hopital's rule, we have already done limits. L'Hopital's rule is not difficult. So I have those 3 areas to look at, and my aim on Tuesday, God's willing, is to complete those 3 areas. Now on Thursday, God's willing, which will be the final class, it's just for us to put the icing on the cake. I need to go through 1 or 2 more graphs with you, and I will set the pace, the tone of the class, do what I know I need to do, and then open it up for those areas that you may want me to revise, and I can use that within the last 3 hours. And in the following week, it's going to be yours. Send you off for your exams and the whole stuff. But I'm going to encourage you. I just want to get this housekeeping out of the way. I'm going to encourage you. I'm seeing movement on Edithasoft. And there are some of you who are dragging your feet. You notice I don't come to class to speak about it because I've spoken about it once before. I said, move, go ahead and continue to stuff. 20% of your final grade will come from the platform. 20% of the final grade will come from the platform. So I'm encouraging you to spend some time to complete your medical sub. All right. So I'm
Just
going to give you.
20%, sir?
Say it again.
Just 20%?
20% and 20% and 0% virgin.
No, man, Edico South, so no, so
20% and 0%.
that's just the service 20%?
Okay, Jeremy, 20% and 0% here. You know, many students don't want 3 more percent for pass the course. Say it again, mommy.
How much the final word?
60%.
Sir, just 20%?
You need to leave me alone.
The final how much, sir?
The final paper, the final is 60%.
Oh, 60.
Yeah.
Damn.
Exactly, Jeremy, and the just 20% is a valid question.
Say it again. Let me hear you say it one more time.
So why the
Just-
final be 60?
Just
That's
20%.
So I,
They all at 30%.
yeah, mama take a 30 or 35.
Out of 40?
Edico South, and then give 5% for midterm.
You're the plan. Do my last question number 4 here.
Oh, Jeremy, and you're going the wrong direction.
All right. Oh, 35 for the
Finance about 50%.
Funny enough that you said that, I was in a conversation one day this week. Today's Thursday, yeah, one day this week I was in a conversation with someone, somebody who has clout in terms of, you know, making decisions. And I said the same thing. I said, you know, it's a pandemic. Let the continuous assessment be weighted more and the exam be weighted less. But of course, that's.
So you realize that 1 week
Oh.
ago,
Exactly.
you realize
Yes.
we have only 1 week ago of ours material, right? And
Oh
for me,
no, no, that's not true. You had 3 weeks to go for it. You had
So,
2 weeks
sir,
for
you-
Christmas.
sir, and a year course alone, sir. Come on.
You know, but you have to be pacing. Hello, another course I don't teach. And I had to be pacing myself and preparing notes. You say, all of these stuff, you know, some of these stuff I didn't have in mind. I had to sit down and prepare that there. Well, I had done the L'Hôpitals before, but
So
the
you was
exponential.
one time a student measure, so you know what I know.
Oh yeah, and I can tell you, I know what I had to do, and I remember carrying several of these courses. You know, and you talk about study break. The Faculty of Pure and Applied Sciences then, them don't have Pure and Applied anymore. Them have Science and Technology now. The Faculty of Pure and Applied Sciences, it is little time you when I exam and sit down and cry. Little time you literally sit down over the exam paper and cry. Wait up my exam paper, and I said, okay, now that I'll release the stress, start working. Because we have class Friday up to Friday. All right? And I don't know why it is with the science students, or exams are the first set of exams. So remember, the class finish like at 6 o'clock on a Friday, you know, and sometimes later depending on the courses you're doing. And exam period start in December. On the Monday, the first exam is a science exam. All right, so you have to be on your tippy toes. Tippy toes. So I'm telling you, and it's not like when it comes, I will say to you, say, boy, you know, so I expect this to come. Then the lecturers, they're not telling you nothing. You better grab past people and start working yourself. You understand? Real talk. Real talk. It's people talk about, oh, Excel, wicked and so forth. I don't say nothing to them. Go somewhere else and find out how wicked them can be. All right? But yeah, man, I say it, man. Yeah, but anyway, start this one for me, please. I give you 5 minutes.
Sir, but that is something to really consider, letting the coursework worth 60% and the exams be 40.
Yeah, it's a conversation that I think we need to have, because I mean, of course, it's the whole pandemic and the whole stuff. I mean, especially for the pandemic, you know, it you know, or have a 50-50 or whatever it is. But it's a conversation though that I was having. But as I said before, the CCCJ is not just Excelsior. There are now 10 member institutions, and when they go to council, all the member institutions will have to take a vote, and the majority will push forward. And final thing I'm going to say on this, you need to remember when, well, it did affect us because we are year 3 students. So we started in September, early September. But
Yeah.
my Cape students, I only started teaching them on the 25th of October. And when Excelsior went to council and begged them to push back the semester because XYZ support and so on, the other institutions said, oh, no, it's not going to affect the support and so on. And in the long run, when them realize it's going to affect them, they call emergency meeting, and everybody had to push back until the 25th. So I'm saying to you, sometimes because Excelsior is the first community college, and we have been there and we are experienced. You know, the other member institutions don't often listen to what we are saying, because they may not have experienced some of the things that we are experiencing. So, you know, they may vote against it, and not, of course, majority runs. So that's the thing. But I mean, it's a conversation that I'll raise again. So you may not benefit from it, but your other colleagues, maybe in first year, will benefit. Who to tell me they benefit from it in year 4? So let's just see what happens. All right, work on it, Sonny, please. 5 minutes.
Right.
Get as far as you can possibly get to, and then we'll see where it is that will go.
So, sir, for these type of questions, the only additional thing they can do is ask us to find the particular solution.
Yeah. And all you do with that is just substitute.
Crazy glue, sir. Crazy glue.
All right. Were you able to separate the variables?
Yes, sir.
Okay. So tell me if you were able to separate the variables that way.
Yes, that's what it looks like. Separate.
Okay, great. Now, and again,
And this time I integrated the left side. Yeah.
right, so you have gotten ln, the absolute value of y.
Yes, sir.
Good. All right. Now, you notice you have a, all right. So this one here, by the way, before I go there, did everybody get the variable separable up to this point?
Yes, sir.
Great, great, great. Now, the thing about this one here now, let's just focus on this piece here. The calculus 1 syllabus, I find it leaves for a lot of interpretations.
Sir, that feel like the whole of this semester.
No man, the other areas are fine. It's just that
No,
for
I'm
this.
not talking with your course specifically.
Oh, okay, got you. Yeah. This part of the syllabus, differential equation, I was excited when I saw it on it, but I find that it is not as explicitly stated. And I did say to you at the start of it that I am reviewing the curriculum, and that 1 week that we have on a semester break is when I'm going to be finishing with the review of it. And this is one of the things I'm going to be writing about. For example, log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. That will be used in order to do the differential equation for the for case 4 in one of the earlier examples. And in the other example, you recognize that I ended up using the subtraction 1. So in the differential equation, I would put something to say review of logarithms. And if not review of logarithms, that we need to teach the laws of logarithms. All right, because it becomes important. So that's one of the recommendations that I will make it for this area. But look at what is happening here now. The integral of x over x squared plus 1. The integral of x over x squared plus 1. That is, it's not partial fractions, but it is a special type of integration. All right, now watch me. When you differentiate the denominator, what do you get? When you differentiate the denominator, what do you get? Talk to me now. When you differentiate x squared plus 1, what do you get?
2x, sir.
You get 2x. Very good. You get 2x. All right. So you're gonna have 2x out there, but because you differentiate it to get 2x, you have to reciprocate it. So you're gonna have 1 over 2x. You're gonna have 1 over 2x. So you're gonna multiply that fraction by 1 over 2x, and then you are going to have 1 over 2x. That means the x in the numerator will cancel out with the x in the denominator by the 2x. And you don't have to worry about it. I can write this out for you. Don't worry about this part. And then no, so the integral of x, 2x. Here, you're going to differentiate this portion, the 2x, the x squared rather, to give you 2x, right? Then you have to now reciprocate the 2x. And when you reciprocate the 2x, you're going to get 1 over 2x. That means the 2x is going to be the denominator. The x in the denominator will cancel with this x in the numerator, and then you're just going to be left with a half. And this is how we get the half. And because you're going to end up with a 1 right up here, so 1 over x squared plus 1 is going to be ln x squared plus 1, and that's how we get the ln x squared plus 1 right here. So this is a different type of differentiation, integration. You notice I didn't spell it out because this type of integration is not stated based on what I would have read in terms of integration. So you notice I did not teach you that law. I will go back again, look at it, for class on Tuesday to say, okay, I find exactly what you're talking about. But for now, let us just leave this as it is. And then we would have gotten here. And let me show you how we're going to convert here. So we'd have gotten here. Again, we're going to let C to be equal to ln k. We're going to let C to be equal to ln k. So I'm going to have 2 ln's. And again, the law comes back to haunt us. Log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. So it's going to be this times all of this, k plus 1 times k, but it's going to be it's going to be k times x squared plus 1. So k times x squared plus 1, and then it's going to divide by this 2. And this 2 is right here. So this is going to be what it is. As I said before, there are 2 things that I need to go back on. And every time I talk about it, it says to me, go back and look at it, Mr. Shan. And that's exactly what I'm going to be doing. I think I had given something with particular part here. Hence determine the particular solution. If that part is easy, because you just substitute it into the original function, and then you get your final answer. All right, which is going to be that. So what I will do is, and I don't think I've generated any more questions. What I'm going to do is, I'm going to look back at the curriculum. I want you to also look back at the curriculum. We are at the final class next Tuesday to complete your stuff. I will speak about it. I'm going to look back at the curriculum. I will say to you, I'll even project the curriculum so we can look at it one with another and make that stuff done up. Okay, Jeremy, so you did say that there's a whole lot of stuff for us to go through in preparation for that 1 week. And it's true. It's a lot of work. So I'm going to ask you, today's Thursday, that this weekend you put aside some time for your Calculus 1. It's very important that you put aside some time for your Calculus 1 so that you can get some good studying, in play.
So, take a solution.
Go ahead.
For the for the Elecosaf, it's like we could do 3 at the exam and you use that with 20% instead of all right.
Have a wonderful rest of the night, Jeremy. But I don't know what can I say. Jeremy, anyway. Jeremy, leave me alone. You and your niece, leave me alone. It will not happen.
I had a class that already, and the person who just used 3 of the grade.
No, say it again. You had a class with me before, and that's what I did?
That with you, but at least take us my push up away, sir.
No, hold on. No, I
I
didn't hear that. I didn't hear that. You said who used 3 of them?
And next, no, about that was I was saying.
Oh, another lecturer used 3 of them. Oh, that's a bad lecturer. But you had a class with me before?
Have you had a class with you before?
Mm-hmm.
Yeah, that's what I say. You can do that.
And how many did I use when you had a class with me before?
All of them.
Okay, thank you. Have a wonderful rest of the night. I'm so happy that you answered yourself the question.
No,
wonderful rest of the night.
So yeah, difficult sometimes.
Jermaine, you know the love is there. I care about the whole of my students, but guess what? My students need to care about them teacher too. Wanna do the work, please? All of them are going to do the work here. Have a wonderful rest of the day. Bless in the heart. Sleep tight. Say the gentle Jesus, all right? Bless up.